Hello, I'm David Craig, CEO of Isotope, and I'm here to talk about today why sustainability is such a hot topic for data center operators and their customers. The next slide that we'll show here brings up an idea of kind of what's been happening over the last decade. In 2010, the cloud was just really something that covered our skies up. Coming from Scotland, I kind of know what that really means. By 2015, we'd started seeing a proliferation of devices. Millions of them. By 2020, we've now got billions of devices, and those devices draw significant amounts of energy and water and have a real impact on our environment. Much of it people know nothing about. This is an issue for operators and owners. Customers are unaware of it as yet, and as they become aware, it will become a really pressing issue in reputation, but also to meet the sustainability targets all our governments want to do. We must think differently and we must change. I'm going to tell you a bit more about why. When we think about climate, people often think about carbon footprint, either their own personal footprint or indeed air miles and all the other stuff that goes on there. But we like to think about climate in a number of different ways because it draws some different conclusions, and it's all part of the emerging problem. So we genuinely have a climate issue in as much as we are generating and producing significant amounts of carbon, and we're consuming vast amounts of water just to run our data centers. And we'll talk more about the numbers on that. But we've also got an emerging different legislative and political climate. To some extent, globalization has been checked, and we're seeing superpowers start to position and try to hold power against each other. We could be looking at a Cold War in data. Now that requires international organizations, customers and people to suddenly have to think about being in different jurisdictions, which means data living in more places, which means we need to move it more, we need more data centers, and of course we end up using more and more energy. We're also looking at things like GDPR, where we have legislation that requires us to know where our data live. And then, of course, we have the real environment that we live in, which is often harsh. And the technology that's there is driving us to the edge. We want to do more with new applications. And of course, what happens in doing that in this place we call the edge, it's the place outside the cloud. It's the place where we do our compute other than in the cloud. And we're doing much more heavy lift there as AI, AR, and other applications come to town. And that's a really important issue for us. We'll talk about the data explosion and we'll come back and talk to the edge, but we have to be very careful. Data centers are one thing, but what we do outside the data center is a sustainability disaster in the making if we don't act now. So what's all this data? Well, back in 2010, we were generating about half a zettabyte or so international of data a year. Most of that in Oracle, SAP, and all the other types of systems that we had. And that grew gradually by 2015, and video and such like was starting to become a media type that people would store and work with. And then the explosion in the next 3 years was a 30x increase. And it's exploding again. We're seeing another 4 and 5x increase in the volumes of data we have, much of it unstructured. It's video, images, and a lot of it is structured in the format of CAD, CFD computations, and so on. But these are incredible volumes of data, and we have to store them, we have to process them, and we have to move them. And those things all take huge amounts of energy. So I've talked about content types and things that are driving this, but what are the real drivers of those content types and this data explosion? We often talk about the Internet of Things. That's all these devices we carry. It's iPads, iPhones, it's Galaxy phones, it's fridges, it's smart stuff everywhere. We've got sensors, we've got measuring devices, and we've got things that create and move data around. And the IoT is exploding and causing more and more data. And the more we have, the more we refine, the more we want to do things with, and the more we create. It's a never-ending cycle of data creation. We have massively improved the ability to move data by having better processing speeds and better bandwidth. So the more we can do, the more we want. We've developed incredible deep learning, and also we've really opened up the ability to have all these 5G and 4G networks and 6G emerging in the future, which allows us, again, to access data in the most remote and the most widespread areas. And particularly there's a big shift, of course, also as more people become middle class, as more economies emerge, then we're seeing 1 billion more middle class every decade or so. And all of those people, quite rightly, want to live the kind of lifestyle that we do in the West, and they're going to want to have iPhones and iPads and all the other devices that come with it. So they're going to be using those, they're going to be generating data, they're going to be moving it, and we're going to have ever more consumption. So what's the issue here? Well, to manage all of that, we've got an incredible rise in what we call chip densities. The processors that live in our computers are just getting much bigger. And as they do that, they're getting much, much hotter. And we have to cool those down. Computers don't live well without being cooled down. They need to be kept at some kind of constant temperature. And historically, we've just blown air across them. We have data centers full of fans, and we blow chilled air across them. That chilled air consumes huge amounts of energy. We're going to talk about some of that as we go through. And it consumes huge amounts of water, which is kind of the subject that people don't really talk about. And we absolutely need to put that on the agenda. If we want to talk sustainability, we need to talk water. The other one is land. Building a data center, particularly traditional types, if you're out in the countryside and whatever else, some of these things are acres wide. There are about 500 hyperscale, that's these huge cloud data centers today on the planet, and maybe about another 120 in build. That's the equivalent of about 18,500 Wembley stadiums or Dodger stadiums in physical area already. And we're going to need more of them. And yet we have huge amounts of brownfield buildings that, if we could use different technologies, would suddenly be available to us. And we can better use space. We can also massively compact space using better technologies in the cooling and the infrastructure management of these data centers. It makes them not only much greener, it makes them much, much cheaper. And that's a really important thing for us to understand. So big changes that are coming also is, because of that water usage, there are going to be many, many more restrictions. California, which is a drought state, has data centers which use the equivalent of 60,000 Olympic swimming pools of water a year, chilling them down. As people start to become aware of that stuff, it's going to cause a real issue. We're deploying IT into ever harsher environments. Because we can do this stuff, we're having to take it to places like agriculture, power utilities. We're going out into the built environment to help us better manage autonomous vehicles and communications and all the other stuff that our smart cities are going to have. And importantly, there's a rising awareness of environmental concern. There's a political awareness and emergence really coming through here, and it's absolutely important that people understand that these things can turn overnight on a coin. We don't have years and years to work this stuff out. We have to act. So we think about the energy consumption that's here. This is a super interesting slide. Global demand for energy is hundreds and hundreds of terawatt hours. It's over 200 terawatt hours already just in data centers. Now, what you do see is that we've been doing a good job of managing the growth of it in the infrastructure side. So we're being more efficient, but there's much more we can do. You'll also see, though, that servers themselves are getting hotter. And as they're getting hotter, they themselves are consuming more energy. Just onboard cooling of servers takes up about 10% today of their energy. And we're seeing forecasts of 15 to 20% of server energy just cooling it down. And that energy is often missed from all of the energy calculations. And it's really important that we understand that energy draw. Interestingly, as we move on to this next slide, what we see here is where that energy demand is sitting. And the good news is there's been an increase in the hyperscale data centers taking it on. Hyperscale, although it's huge and it's there and it's going to get focused because of its size, has been a good thing. It has data centers that are 30 or 40% more efficient than classic enterprise data centers. So as the enterprise has given up its data centers and gradually moved out of them, it has allowed hyperscale to grow and to take more efficient data centers. But there's so much more we have to do. Cloud and hyperscale, to some extent, are similar technologies and similar things here. I wouldn't really separate them out terribly, but the creators of this graph did. Importantly, what you do see here is that the enterprise is reducing massively as a proportion, but actually you'll notice it's still drawing more energy. Enterprise data centers are usually terribly inefficient, but bizarrely, even though they're on the way down, they're consuming more energy. They're working harder and they're more inefficient, and we have to have a real think about how we do that. The good news is increasingly enterprises are moving to co-location and to hyperscale. That's a good thing, but they will start to receive much more equipment coming back out in the edge. And again, if we don't green the edge from day one, we'll be in serious trouble. Most edge installations are almost twice as energy inefficient as a good data center. That's a real issue for us. Estimates are that 50% of our data will exist in the edge outside the cloud by 2025. If half our processing and storage are at those type of efficiency levels, and because they're all dotted in small installs, we really need to think about that. I'm going to talk about water. People don't really understand this. A typical data center drains an Olympic-sized swimming pool of water every couple of days. It's hundreds of thousands of litres. A hyperscale data center, one of these large ones that you see there, consumes the equivalent of 3 massive, large city hospitals every single day. And if you think about all the stuff that hospitals do with water, for hygiene, for cleanliness, for operations, for systems that they run, heating, these are massive consumers of water. And a single hyperscale data center is the equivalent of 3 of the largest city hospitals you've ever seen. In fact, we use so much water in cooling stuff down, and that's all it's doing. It's enough water globally to hydrate 10% of the world's population. Think about that. 700 million people could be drinking water 3 litres a day that we use just to chill and cool our data centres down. Those numbers will become much better known, and we will have to do something about it. And in total, at this point in time, just our ICT and data centres is taking up 3.5% of global emissions. That's the contribution. So we're larger than the impact of aviation and shipping, and we get away with it because people don't really know who we are and what we do. So as we look at energy consumption, why don't more people do green data centers? Well, the answer often lies in nobody getting fired for designing a data center the same as they designed the last one. Data centers are an operation in risk management, and we understand that. It's important to understand how they work, how they operate, and they're very complex organisms. But if we just maintain that incrementalism, we won't be able to achieve all the sustainability targets and goals that we must achieve. And if we just keep building data centers the way we do today, what will happen in a few years' time is those data centers will just become unworkable. They will become albatrosses around their owners' necks. The reason for that being is they will be unsustainably expensive to run, and they will have massive costs of restructuring because legislation will force them to. It's really important. We're on the cusp of one of those great changes where incrementalism doesn't work, where timidity, fast following, and all those other strategies doesn't work. We have to do something, and we have to act. A green data center can reduce the environmental impact by over 80%. In fact, my company has recently just received a report, which we're going to publish, which demonstrates that we can be into anywhere between 11 and 36% gross efficiency more across all devices, across cooling, across servers. The whole data center can be 11 to 35 or so % more efficient in energy than the best in class that we see in the world today. And we'll talk more about that in another session. That consumption and that reduction by going green is enough energy to run Vegas for 37 years. And we've literally got a handful of data centers that comply with any way, shape or form with green, and we can make them greener. Talking about that energy again, a single 1 megawatt of a data centre per annum produces almost 8 million pounds of CO2 to the atmosphere. Looking at a large cloud scale 150 type megawatt, that's at the high end of them, but there's plenty of them there. The carbon equivalent of those would be like driving 1.3 billion miles in an average passenger vehicle. And the carbon absorbed by over 6 million acres of US forests in a single year. When we start to think about it in those terms, we start to really understand what we're doing here. And bear in mind, we're operating in hundreds of times those numbers. So something we would also say when we've talked about space and such like is in building these data centers, it isn't just the energy they consume, it's the carbon footprint of building them in the first place. And we would agree with people that believe that the cleanest data center you can build is the one you already own. There's quite a trend in people closing down inefficient data centers. Now, there may still be good reasons to close them down, but if the reasons were they've got old inefficient stuff and all we can do is buy slightly incrementally better old inefficient stuff or new inefficient stuff, and we can't make them work economically, we're missing a trick here. The ability to densify and to get 2 and 3 and 4 times as much compute power into those buildings is eminently possible with good, well thought through retrofit using technologies like my company. When you think about the sheer volumes of data center space where we're taking up millions of square feet, we have to think again about the amount of concrete, of steel and other materials that we use, and then in how we manage to make them both energy efficient as we go. We've got some slides here and I won't spend a lot of time on them, but again, reusing buildings helps to cut carbon emissions. Those kind of impacts, as we start to understand where we are with those data centers, sensibly reusing a building is equivalent to removing 2 or 3 years of a commercial office building. Think of all those hundreds of offices, 30, 40 floors, lights on, computers, or 200 server cabinets operating in a year. These are savings that are worth having. I've talked about the need for us to better reduce and care for stuff. We've got an absolute imperative, both morally, legally, and technically, that we have to do here. We have to consume less energy and we have to allow ourselves to grow. We can't stop growing. We have to allow ourselves to expand. We have to allow people to come out of poverty and join in being part of the modern world, having devices, having lifestyle. We have to allow those things to happen. So to do that, we have an imperative and an obligation to do so in a way that doesn't make the climate crisis any worse, and which can allow us to enjoy new business models, but also to do so in a way that's profitable. As I've said, we can help you, we can do this in a cost-reduced way in CapEx and OpEx. But it does require change, and it requires us to stop thinking the same way we've done for 40 years, and it requires us to stop incrementalism. My company Isotope is based in the UK, but we have a global presence. We do a thing called liquid cooling, and to be honest, I think liquid cooling is a misnomer. It's the technology heart of what people do. So we do this liquid cooling thing, and lots of companies do. But frankly, there's several technologies out there which are well known, and they're just evolutionary dead ends. There are real form factor or performance issues or limits to what they do. They often add cost instead of removing it. And importantly, what we did was to look at the best of those things, kind of draw the Venn diagram, circle round that. And we came up with a thing we call chassis level cooling. Chassis level cooling looks and feels every bit like your servers do today. They're in racks, they're in chassis that come out and forth. You can hot swap. You can do anything you want, servicing them while they're running, you name it. Everything fits there. It works with your local integrator. It works with your infrastructure. So yes, there's a change from moving air around to moving liquid, but that in itself is hugely less expensive and massively reduces our carbon footprint. Using liquids to cool removes, to a typical enterprise data center could be 80% less energy consumption. Even against some of the best data centers today, you can still be looking at 30% energy reduction. Water is getting close to 99.5% reduction by using technologies like ours. But importantly, uniquely, we cool the whole stack, spinning disks, servers, switches, GPUs, in any scale across the whole estate, from hyperscale to the first hop edge. No other company can make that claim. And we're doing that for some really amazing companies. We're not going to name names here, but we are working with some of the biggest hyperscalers and the biggest tier ones in the planet. And do look at our social media and all the other stuff where we make announcements about things. We've got a number of different technologies. So we've developed a platform. We've got a business model that works and removes us as an issue in your supply chain. We've got full agnosticism around coolants and server types and all the things that you want to do. So it's insanely flexible, and it allows you to work and have all the supply chain policies you've wanted and to remove all the risk of that change. We've designed the technology in a way that's really easy to service and maintain. You can pop lids open, hot swap, hot service. It's as simple as that. You don't need to lift stuff out and drain. You don't need to turn whole racks and cabinets off to access it. You don't need cranes to lift things out. You don't need to have water coming in close to your electronics. So it's a really important thing that we can do that. And the great thing about us is we've got real longevity. We have future-proofed into a world where not only do we cool the things that exist today, we haven't hit a thermal limit we can't meet. We can take you beyond the limits. Not only are we a problem-solving technology, but we're an enabling technology for the future. I'd love to be able to tell you more, and I hope if we've piqued your interest, do contact us. And thank you for paying attention. Thank you for your time. I'm really grateful for it. We love our industry. We love what it does. It does many, many good things. It's at a point in time where its positive contribution can continue, and we'd love to be there to help that change happen. Thank you.